Welcome back, Night Owls. This is Dr. Nighttime, and tonight we're going to talk about logarithms and the change of base formula. Now, this change of base formula, which is often considered the hardest formula to work with in a standard log section of an Algebra 2 class, the formula itself is actually way simpler and more intuitive than a lot of teachers make it out to be. And I'm going to explain how it all works here. So first, you'll notice down here, I have a number line. But it's not an ordinary number line, where the spacing between the lines, these were supposed to be evenly spaced. I kind of eyeballed this. But yeah, if you could imagine these are evenly spaced, right? The evenly spaced numbers, it's not that you always add the same amount to go from one to the other, right? It's that you multiply by the same amount. In this case, numbers one space apart, you always multiply by 2. Numbers 2 spaces apart, you multiply by 4, right? Here to here, 1 times 4, it's going to go to 4. If I want here to here, 2 spaces apart, 8 times 4 is 32. Works going backwards and forwards. Note I can only get positive numbers here, right? No amount of multiplying or dividing by a positive number can ever make you go negative. Since the scaling between consecutive numbers, it's a scale factor of 2, right? To go from one number to the next one over, you either multiply by 2 or I guess divide by 2 if you're going to the left, right? But 2 is that key number here. That's called the base of this logarithmic number line, or a multiplication number line if you want to think of it that way. So with that base, the log question asks, how many steps would you have to go to the right to reach whatever number? So for example, if I wanted logarithm base 2 of, let's go all the way up to 4096. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. Or if I wanted, let's say, log base 2 of, let's say, 1 over 256. So I start at 1, and I start at the center, and go over 1, 2, 3, 4, 5, 6, 7, 8 steps. But since I'm going backwards, right, that it's like going negative 8 steps, right, because I'm going backwards. Okay, so that's how to deal with this in base 2, right? What if we wanted to measure in steps of 8 rather than steps of 2, right? I'm choosing 8 because it's a nice power of 2, and the 8s show up on here, and the powers of 8 show up on here, right? So if I were to say, okay, here, one step would get me an 8. I go over 3 more. Another step would get me 64, right? 8 times 8 is 64. The old kind of gross mnemonic, I ate and I ate, I got sick on the floor, 8 times 8 is 64. I guess here we've got our 1 right there, right? Okay. So if I wanted to know log base 8 of 4096, right? Okay, I mean, it lands right here anyway, so I can just go 1, 2, 3, 4. So I can say log base 8 of 4096. That would give me a 4. Okay, what if I wanted to try to relate logarithms of a given number, but one with base 2 and one with base 8? Well, so if I wanted to calculate log base 2 of 4096, and I didn't already count it out and get to 12, right? It seems too laborious to count out this many, right? Well, once you've got these blue lines here, if you were to ask, hey, how many little steps would I have to take to get out here? Hopefully, what you could try to say is, well, if I wanted to go from this 1 in the middle to 4096, I could say, well, it's 4 blue steps, and each blue step is 3 little black steps. So I could try to say log base 2 of this 4096, If I didn't want to count all that much one at a time, right, I could say 3 times 4, right? 3 little steps per big step, and 4 big steps to actually get where I'm going. Or I could say log base 2 of 4096. If I wanted to remember what this 3 and this 4 represent, the 3 represents the number of little steps in one big step. Log base 2 of 8. And the number of big steps to my destination, right, that's going to be log base 8 of 4096. This is what I call log chaining, right, where you could find an intermediate base. Right? In general, there's nothing special about the numbers 2 and 8 for this to work, right, of just wedging an 8 kind of between here. In general, you've got the equation log base A of some number C can equal log base A of B times log base B of C. Okay? And we're just using this idea of if I have to count, little steps in some bigger, easier to work with step size, and then count the number of big steps to get where I'm going. Right? That's this idea right here. And this can work if I'm trying to work with, let's say, a somewhat weird base, right? Suppose I wanted to work with a base of 3. That doesn't show up nicely on here. But if we know that a 3 would be around here, it's probably going to be a little closer to the 4 than the 2. For those of you with any mathematical background in music theory, you might actually know that 3 would kind of be 7/12 of the way towards the 4 relative to the 2, and you'd know that from understanding why it is that 2 notes separated by a P5, a perfect fifth, 7 semitones apart, why that sounds so harmonious and is considered perfect fifth, and then from here to here would be 5/12, corresponding to 5 semitones. Those of you who know that, okay. Anyone else, just know that, okay, we could say log base 2 of 3 is approximately 1 7/12. If I wanted to know log base 3 of 4096, I could start with log base 2 of 4096. Okay, that's considered easy to calculate, right? 2 is a nice base to work with in this context. That can equal log base 2 of 3 times log base 3 of 4096. And so if I wanted this log with a weirder base, right, I could just divide by this log base 2. So that would be approximately 12 over 19 over 12, right? Which would get me whatever 144 over 19 is. Again, just as a pretty good estimate. Again, this is relying on knowing what log base 2 of 3 is. Or in general, right, our general algebraic rule would be log base a of c. If it were easy for me to find logarithms with base b, maybe because you've got one of these machines here that can handle log base 10 and log base e, right? And so if you have a log of the wrong base, you could say that this would equal log base b of c divided by log base b of a. You're using this idea, right, calculating this out, and then realizing, okay, there's nothing special about the numbers 2, 3, and 4096 that I picked, right? I could just do this algebraically, right? Just translate the variables over. And there we have change of base formula explained just by using a number line. I hope you found this helpful. And as always, if you like the way I explain things and you want to arrange private lessons, click the link in the description below. Until next time, this is Dr. Nighttime wishing you a good night.